Hello guys, welcome back to another video. In this video we're going to talk about AP Calculus free response questions for 2000. Specifically we're going to focus on the question 4 on 2000 AP free response. Okay. So basically in this problem it says water is pumped into an underground tank at a constant rate of 8 gallons per minute. So basically at the end of the 2 minutes there's going to be, at the same rate, there's going to be 16 gallons of water, and at the end of the third minute there's going to be 24 gallons of water. Okay, and then it says water leaks out of the tank at the rate of this. So let's call this function like L of t equals square root of t plus 1. Okay, and then this is our time interval from 0 to 120 minutes, and at time t equals 0, the tank contains 30 gallons of water. So this is our initial amount of water. Initial gallons of water. Okay. Alright, so let's see. In the first problem it says, how many gallons of water leak out of the tank from time t equals 0 and time t equals 3 minutes. So basically, so the part A, it's basically about the accumulation problem. So whenever we are dealing with the accumulation, we always use integration to find the total amount of gallons of water leaking out of the tank. So basically, the way I'm going to set up the integral will be like this, from 0 to 3, and remember that this function represents the gallons of water leaking out of the tank. So square root of t plus 1 dt. Okay. So in order to deal with this definite integrals, first we need to use a u substitution. So I'm going to set t plus 1 equal to u. Then if I differentiate, I'm going to get dt equals du. Alright? And of course, whenever we do u substitution for definite integrals, we need to change the upper and the lower bound. So basically, when t equals 0, u is going to be 0 plus 1, which is 1. And when t equals 3, u is going to be equal to 3 plus 1, which is 4. So basically my new upper and the lower bound will be from 1 to 4. And I'm going to switch t plus 1 with u. So it's going to be square root of u du. So we know that this integral is going to be equal to 2/3 using the power rule. 2/3 times u to the power of 3 over 2 from 1 to 4. So basically, if we apply the first fundamental theorem of calculus, which is telling us how to evaluate the definite integral, first I'm going to put 4 into this expression for u and 1, and we're going to find their difference. So basically, so when I do that, I'm going to get 14 over 3 gallons of water. Okay. In part B, let's move on to part B. This is how many gallons of water are in the tank at time t equals 3. So basically, the way we approach this problem is that, so total amount of water, so that's going to be equal to initial amount of water, plus the water being pumped into tank first 3 minutes, and minus water being leaked out of tank. So once we set this up like this, so it's going to be, so you're going to understand much better. So we know that the initial amount of water is given in the original problem. It says 30 gallons, 30, and plus water being pumped into the tank at the same rate. It says at a constant rate of 8 gallons per minute. So basically at the end of 3 minutes there's going to be 24 gallons, as you can see, plus 24. And in part A we just found out that the total amount of water leaked out of the tank is 14 over 3, as you can remember that. So 14 over 3. So basically this result is going to be equal to 148 over 3. So basically at the end of 3 minutes, this is how much of water we have in the tank. Alright, let's move on to part C. In part C it says, write an expression for A of t the total number of gallons of water in the tank at time t. So for any time, like in general. Okay, so basically A of t is going to be equal to the initial amount of water, which is 30, and plus from 0 to t. So we don't know that times, that's why it's going to be very general. So from 0 to any time t, the water being pumped into a tank, which is 8 gallons per minute, so 8 plus an amount of water, actually not plus, it's minus. It's going to be minus. So it's going to be water leaked out of the tank. So minus square root of x plus 1 dx. So basically this expression is going to tell us in general how much of water in the tank at any time. Okay, that's the model that we need to create. So in part D, it says at what time t for 0 less than or equal to t less than or equal to 120 is the amount of water in the tank maximum. So this is the keyword maximum. So whenever we see this keyword maximum, that relates to first derivative. Because remember that if you want to find the maximum or minimum value, first we need to figure out the first derivative and set it equal to 0 to create to find actually the critical points. So basically we're going to find the first derivative of the model we just did in part C. So the a prime of t is going to be equal to d over dt 30 plus, of course we're taking the derivative with respect to time, and d over dt from 0 to 8 from 0 to t, 8 minus square root of x plus 1 dx. So basically when you differentiate the constant number, it's going to be 0, and then this part is going to be equal to just 8 minus square root of t plus 1. Of course we have to set this expression equal to 0 to figure out the critical point, in this case time. So when we solve this equation, we're going to get time is going to be equal to 63 minutes. Okay. So definitely at 63 minutes there's going to be a maximum amount of water in the tank. But sometimes we have to test our answer. So if I want to test my answer, what I'm going to do is the sign chart. So basically I'm going to create the sign chart between 0 and 120, and my answer is 63. So basically between 0 and 63 I'm going to select a time, let's say in this case 60, and between 63 and 120 I need to select a time, in this case 70. So I need to test these values in the first derivative, not in the original function, in the first derivative. This is very important. So we need to figure out what is a of 60, and we need to figure out what is a of 70. Okay, so a of 60 is going to be equal to 8 minus square root of 60 plus 1, so we get 0.19, which is bigger than 0, which is positive. And also a prime 70 is going to be equal to 8 minus square root of 70 plus 1, so we get answer is going to be equal to negative 0.426, which is less than 0, which is negative. So if you may have noticed that my first derivative function changes from positive to negative, at this time, 63, which means our answer is correct. So basically the maximum value is going to happen at t equals 63 minutes. Alright guys, thanks so much for watching. So today we did question 4 from the 2000 AP free response portion.